No, it's not what I was expecting, but it's really like, it's really fast, you know, it's really.
So you're right, you guys like different in you when you know what. Like, so you know, I mean, look at you. I feel like gotcha. I mean, did it, then I feel like lower on grades. No. Oh. Yeah, you don't want to lower on grades.
And the information goes to check.
Okay, first, I wanna, talk about the calendar, for a moment. The calendar that you have, forgot to adjust for the fact that there's no school on Tuesday, so everything in your calendar will be pushed back one day, so, we're gonna, do 3x3 inverses on Wednesday, and everything else gets pushed back, even the test. So the test on your calendar shows Tuesday, but the test will be on Wednesday. So just use arrows to indicate on your calendar that everything is getting pushed back, and indicate on your calendar that the test, Matrices test is going to be on Wednesday, not Tuesday. Sweet. Okay. Now let me just talk about big picture here in terms of what we're doing today. In terms of the work. We already know how to do this, but let me just kind of talk about big picture, and so you can kind of have an idea that really we're not doing anything new. Remember how I talked about this is on page 10. I talked about how if I want to multiply matrices, I can multiply it to get to my resulting matrix. But if I want to solve for a particular matrix, I can move the attached matrix to the other side, and move it to the other side. We don't divide, we instead turn it into the inverse matrix. And once you get it turned into inverse matrix, we find that appropriate inverse, we multiply it, and that result is our matrix B. So today we're just practicing trying to move the one of the matrices to the other side of the equation so that we can solve for our given, or so we can solve for the unknown matrix. So this is really all we're doing today, but there's a conceptual understanding we have to do, but in terms of the work that we're doing, it's just this. So we're going to take the attached matrix, move it to the other side. We're going to find the inverse, multiply it with the matrix on the other side. And so you already know all the skills involved, finding, inverse, multiplying. So today you're going to, hopefully you'll find that it's just things you already know how to do. Okay, but let's go to page 12 and talk about the what we can do in terms of applying matrices or applying systems of equations. So ways to solve two variable systems of equations. So here's a quick example. So system of equation is just two equations like in the middle of the page where you're trying to solve for x or solve for y. Okay, that's what a system of equation is. So there are multiple ways to solve for system of equations. We've done algebraically the elimination method, which we're going to see in a second. Substitution method, where you are trying to solve for one variable and replace that expression into the other equation and solve for either x or y. Elimination method is where you line everything up and you try to cancel out one of the variables so they can solve for the other variable. Graphing method is where you graph the two lines and you just see how many intersections you find. If there's an intersection, then that intersection is the solution. If the two lines are parallel, then how many solutions are there? Yeah, if two lines are parallel, or the two lines that are going to intersect, they're never going to intersect. So there's no intersection, there's no solution. And the third option is where there's infinite solutions. And that is when your two equations are basically the same. It's just one is the multiple of the other. So if you were to graph the two lines, they're exactly the same lines. And obviously, if you have two lines that are overlapping each other, they're going to intersect at infinite number of points because they're going to, they're the same line. So they're going to have infinite solutions. So what does our solution represent? Solution is simply the point of intersection between the two lines. So if you're dealing with two lines and you're looking for a solution, you're either going to get one solution, no solution, or infinite solutions. Okay, so let's do a review problem here. Solve the system using elimination method. So let's practice that skill. Okay, so what we can do is, let me just write the equation again. So elimination method is where we try to multiply one of the equations or both equations with the coefficients so that we can get either the x's to be equal but opposite, so that when we add them, we can get one of them canceled out. So here we can do one of two things: either multiply the top and bottom by 4 to get the -4 and 4 to match and cancel out, or we multiply the bottom by -3 to get the 9s to cancel out. So either way is fine. I'm just going to target the x. So I'm not going to change the first equation. But I'm going to take the second equation and multiply by distribute the 4 through. So 4 times 1x is 4x. 4 times -3y is -12y. 4 times -6 is -24. Okay. So the goal is to try to get one of the variables to go away so that we can just focus on the other variable. So here, what happens with the x's? Cancel out to be 0. So that's what we want. That was our goal. And now we can have an easier time getting it down to one variable and solving for the variable. So -12y plus 9y is what? -3y. Okay, -24 plus 9, -15. Okay, so now if we solve for y, divide both sides by -3. Y is equal to what? 5. Okay, so now that we have one of the variables solved, we can now insert back into one of the original equations and then solve for x. Doesn't matter which one. X equals 9. So we have our order pair. This tells us if there's one solution, this is one order pair. This tells us that these two lines, they do intersect at one point, and the intersection is at 9, 5. So the solution is 9, 5. And that is also, if you were to physically graph these two lines, they would intersect at the order pair 9, 5. So this is elimination method, which is perfectly fine. But we're going to explore how we can solve the systems of equations using matrices. And the way we're going to do that is we're going to use that what I just showed us before, where we start off with the multiplication equation. We're going to do the inverse of one matrix to move to the other side, and then we're going to just multiply. Okay, so All right, so that's our goal here, to try and approach it from a matrix perspective. Okay. So let's explore the same systems of equation. So how can matrices help to solve a system of equations? Matrix equation is going to take on the form of AX equals B. A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. Okay, so this is what we're going to do. Okay. We're going to kind of separate the pieces of this system of equation and put it into matrix form. Okay. So what we're going to do is you're going to start off with a coefficient matrix. So on the left side of the equation, you see how this kind of looks like a 2 by 2 matrix here? We're just going to take the coefficients. So -4, 9, what's the coefficient in front of X? 1 and -3. So we're going to separate the coefficients from the variables. Okay. And now you're going to create a variable matrix. And the variable matrix is going to look like this. You're going to have two variables here, and you're just going to put X and Y. Yes, always going to be the case. You're always going to put your first matrix as a 2 by 2 with just the coefficients. The second matrix will be two variables, a 2 by 1 matrix. And then guess what? The third matrix is going to be 2 by 1 as well. Yep. Right. So if we were to multiply this out, it would end up looking like this. So uh, this is because these represents each of the coefficients, and there's only two variables, so that's why it's only X and Y. Right. But you're always going to set it up this way. Okay, you're not going to have to adjust depending on the equation. As long as your equation looks like this, where you have X and Y equals a constant, X and Y equals a constant, you can always just adapt it into this matrix form. Is your variable matrix, and then B is your constant matrix. Right, we're just putting it into this form. It's always going to be AX equals B. The A is the coefficient, the X, quote unquote, X is the variable, and then your B is your constant matrix. Okay, so what do we want to get by itself? Good, X and Y, right? So that's our goal. We want to get this XY by itself because that's the variable that we're ultimately trying to isolate. Which means that if we want to get X by itself, what do we need to move away from it? The A, good. And here, we're not going to divide by A, but we're going to move it to the other side and convert it into a what? Good, inverse. And it's always going to have to sit in front as close to the equal sign as possible, okay? We never want to put it after the constant matrix. It's always going to go in front, okay? So we're going to move this A inverse to the other side. So now this is what we're going to look like here. XY is equal to, we're not going to do the work just yet. We'll save it for below, but it's going to be the inverse of matrix A times the constant matrix. Okay, so make sure that we don't divide by matrix A. We move it, we call it the inverse, and we have to put it first. And if we can do this work, then we're going to be able to ultimately end up with a 2 by 1 matrix, and we can figure out the X and Y, which should match with the answer that we did before with the elimination method. It's the same equation, we're just going about it a different method. Okay, any questions with the big idea here? Okay, so we're going to use the space below to just continue our problem, right? We've gotten this far. We're going to do the inverse of matrix A. So let's think about what steps we need to take to arrive at the inverse of matrix A. First, we have to find the what? determinant, okay? So we're just gonna put some of the work here, determinant of matrix A. AD minus BC, so 12 minus 9, which is 3, okay, so. And then if I want to find the inverse of matrix A, I got to put that determinant below. Okay, what do I do with the A and D value? Okay, switch them, but keep their signs. And what do I do with the 1 and 9? Yeah, switch the signs, but keep those values there, right? Okay. Yeah. The rest of good number somewhere. Yeah, that's thanks. Okay, so this is okay. I'm not going to distribute the 1/3 through yet because I just want to show you something else that I want to do. But ultimately, this is what we have. We have x, y. We have our inverse of matrix A. So I'll put this in place of this, and I'll multiply by B. But let's see our progress so far. Okay, so we found the inverse. We put it. We found the inverse because we want to create in matrix A on the other side of our equation to get that variable by itself. So now I have inverse of matrix A times B. Any questions? Yeah. So really, we just have to multiply this out, just like how we've done before with multiplication, and then we can solve for x and y. Okay. Now, you have two options here. One option is you can multiply this through first, and then you can work in the multiplication with this resolve times this 2 by 1 matrix. The other option is you can multiply the two matrices first, and then at the end multiply by that coefficient. I think that's what I would prefer, and the reason why is because if you multiply this through, you're dealing with a fraction that you have to involve in multiplication, which just makes it more messier. So my suggestion is save that fraction for the end. That'll make it easier for you to just add and subtract whole numbers, and at the very end, you'll just multiply by 1/3. Does that make sense? So it's not wrong if you multiply the 1/3 through. It's just that you got to deal with fractions throughout the multiplication process, and I would just rather save that fraction till the end. Okay, so that's why I'm going to ignore that 1/3, take care of this first, get this resolved, and then I'll do the 1/3 at the end. All right, so let's just focus on multiplying the two matrices together. So we have a 2 by 2 and a 2 by 1 matrix. So 2 by 2 and a 2 by 1. We know that those are compatible because the inside dimensions match. We know we're going to end up with a 2 by 1 matrix. So that's what we're targeting here, a 2 by 1 matrix. Okay, so just like your multiplication steps, we go from left to right for this matrix, then we go from top to bottom this matrix. Okay, so pair up and pair and add, right? Okay, so -27 minus 54. Sorry, plus 54. Negative 9 plus 24, 24 minus 9. 15. So we're almost there. We know that our variable matrix is equal to, now there's still a what in front. We still got to deal with the 1/3, right? So I just multiply the 2 by 2 and 2 by 1 matrix, but I haven't dealt with the 1/3 yet. So I don't want to forget about that. So multiply the 1/3 through. What's 27 divided by 3? 9. And then 15 divided by 3 is 5. So we get 9 and 5. Okay. Does that match with what we did before? Yes, right. So we see clearly x equals 9 and y equals 5. Okay, so that's all we're doing today. We're just going through these steps, taking a system of equation and get it into matrix form. Find the inverse of your coefficient matrix, put it in front, multiply, and then deal with the that 1 over determinant at the very end. Right. Yes.
So why did you do the 1/3 like last?
Okay, yeah. So the reason why I did the 1/3 last is because if I were to multiply the 1/3 through, I would get -1, which is fine, -3, which is fine, but then I get -1/3 and I get -4/3. And if I do multiplication with -1/3, -4/3, then I got to deal with fractional values when I got to add and subtract, and that just makes it ugly and messy. But it's not wrong. I mean, you can do that. I just feel like we probably would prefer to add and subtract whole numbers than fractional. Yeah, so that's just a suggestion to kind of save some messiness in your work. Save the coefficient for the end. Okay, does everyone understand the process? Okay, so let's practice here. Try number 2. If you feel like you want additional room, just so that you don't have to just fit everything onto that page, you're welcome to grab a scratch sheet if you like. But
Things that didn't want things within it, and it was fun. Right, so two others home. That's the not supposed to be functions. They are. Wait, wait,
2.
oh, this is 3.
Oh, number 3.
Oh,
Determinant is 0, so we stop the problem.
16. Oh, 5 to 7, 16.
Guys, actually, I want you to be familiar with this notation, and I want you to practice it this way. This will be helpful when we when we transition over to calculator work. Okay. So first, are we good with coefficient matrix, variable matrix, constant matrix? Okay. I said that this is kind of matrix A, we want to move it over. So when we move it over, it becomes inverse, but I want you to take this additional step here and keep the same 2 by 2 matrix, but just show that notation to indicate that this is still not resolved. I'm still going to go through my determinant and rearranging to get this all cleaned up, but at least this is showing what I want to do. All right, I want to create my inverse matrix, put it here, and multiply by 2 by 1. So I think this is a good notation for you to practice. So if you guys can write it that way instead of, write it as matrix A, write it with that 2 by 2 matrix. Okay, so now our work is going to be trying to clean this up, right? So find the determinant, put the A, deal with the elements inside the matrix, get this cleaned up, and then we can go to the multiplication involving the 2 by 1. Sorry. Okay, I'll focus just my attention on this 2 by 2 and 2 by 1 matrix, and I'll save that 114 to the end.
Go to multiply the matrix, says we want the inverse version.
First. Is that what sorry, is that what you're gonna say?
Like the whole, A to D and then. So
We do, yeah. So I did that. I went over the determinant, I swapped the 1 and 2, and I changed yeah. So I knew that this was what I wanted to work with. This was the notation to indicate that I'm still incomplete with the process, but now I'm ready to work. Okay. Any questions with yes. I'll come over.
How do you know?
Yeah, just how those are, I mean, those things. Let me get back to you on that. I'm gonna say no, I'm gonna say just no solutions for now. And then if I can find an instance where there's any solution, I'll come back to it. Okay, so I would just like for us to get through number 2 and 3. I'm sorry, 2, 3, and 4. So if we can just get through these problems, just get enough practice, I think that would be good for today.
You know, like if there's no inverse for A, like, I don't know if there's no solutions or.
Yeah, so right now I'm just gonna say if you get an inverse of 0, or if you get a determinant of 0, just say no solutions. I can look into that in terms of how we can tell if there's an infinite many solutions, but for now, let's just say no solutions. Yeah, number 3, you'll go through your process halfway and then realize that when you find the determinant of your coefficient matrix, it's gonna end up being 0, so we just stop the problem and say determinant is 0, no inverse exists, so no solution. Okay. So get through 4, show me your work, and we'll be done. Okay, so number 4, first set up your coefficient matrix, variable and your constant matrix. Move that 2 by 2 over, call it the inverse, and then you can do the work involving the inverse, find the determinant first, AB minus BC. Swap your A and D, change your signs of your B and C. Multiply your 2 by 2 and your 2 by 1 matrix. We'll save that -1 over 57 for the end. Get all the way down to 342 and 0. Don't forget about your coefficients. Multiply through 342 divided by -57 is -6, and then 0 divided by anything is still 0. So x equals -6, y equals 0. Let me look real quick to see if there's anything else I want to go over last minute. Any questions? So, after we come back from break, we will have a few more topics to do. Go through those real quick. We'll do a little bit with 3x3 matrices. It's a lot messier, so there's only certain things we need to do with the 3x3 matrix. But what's gonna take more time are the word problems. So once you get to the word problems, we'll try to spend a lot of time with them and see if we can adjust to those different, see if we can adjust or basically take those word problems and fit it into a matrix so that we can solve. Okay. Yeah, so just a few more things that we need to get through, and then we'll have the test, not next week, but the week after next, I'll like that, yeah. All right, come up and get your votes.
My jumps.
Okay, so we'll. On scout, let's go. I did the one.
Yeah, we.
Right here.
Yeah.
Yeah, I saw that. I think they're
I'll
Really
do
was it?
We'll do that one.
Sure.
Yeah, it's fine.
It's fine with
Yeah,
that.
yeah, yeah. The Christmas.
Sabrina, I'm looking slowly versus. We get out and we have. You know, I'm gonna be special. She goes, I don't do the next day. Only I just see them. That's what she said.
Okay, that was kind of a.
Oh, you guys,
Like, I studied.
I studied. I studied.
Yeah.
I studied for it. It was like 8 words, like it wasn't much studying. I studied different ways.